f of x equals sine squared 4x. So sine squared 4x. Okay, so again, just continuing with the chain rule, so it's a function of a function in this case. So what I'm going to do is rewrite this power just to make that really clear. So f of x, if I just rewrite this as sine 4x all squared. Now, in this case, you'll see we've got the three functions that are all packaged within each other, so function of a function of a function. Again, we need to differentiate from the outside in, so the outside function is the square, the next inner function is the sine, and then the very inside function is the 4x. So f dashed of x, differentiating the square first, that becomes 2 sine 4x. Now bear in mind, just become power 1, so it's just 2 sine 4x is fine. We then want to start multiplying by the derivatives of the inner functions, so sine 4x would be the next inside one. Sine would go to cos, so we get cos 4x. And then we want to get the derivative of the innermost function, the 4x, which is just 4. So we get that, and then just a case of simplifying, so 2 and the 4 get me 8. So I have 8 sine 4x cos 4x. And then we can use our trig identities here just to simplify this a wee bit more, like we did with the red over here. Again, we've done our chain rule part. Let's just making it look a bit simpler, a bit nicer. So just remember the rule just in green, just so you can see it. That like we did there. So 2 sine a cos a is equal to sine 2a. And you can see this part here, it looks very similar to what I've got there. What I'll do is just rewrite it just to make it a bit clearer. So let's say that was 4 times 2, because 4 times 2 is 8. It might have been easier actually in that step, to be honest, but so 4 times 2 sine 4x cos 4x. So in this case, if my a up here, if my a is actually 4x, then it becomes sine 2a, so it becomes sine ax in this case. So that 2 sine x, just underline that in green, that 2 sine 4x cos 4x would just become 4 times sine 8x. And there's a lot of good reasons why you might want to change that into, like for instance, want to integrate. That's a lot easier to integrate than this is, for instance. Obviously that's in the future, but it's nice to spot these trig identities hiding in there. So 4 sine 8x. And the very last example, part H. So here we have a quotient, so a fraction. So f of x is equal to 1 over sine 4x minus 5. Now, we're doing chain rule right now, but we'll go into the product rule and then the quotient rule. So this is a quotient, a division, a fraction. We can do this also with the quotient rule and the chain rule, but we'll just use the chain rule. So in order to do this, we don't want to differentiate something on the bottom of a fraction, so we're going to bring it up to the top. And when we do that, remember that just changes the power to a negative. So the power on this is just all to the power 1. So when I bring this up to the top, there's a nice square bracket. 4x minus 5 to the power negative 1 now. And then I can go ahead and differentiate this. So outermost function would be the power negative 1. Then the next inner function would be the sine. Then the next inner function would be the 4x minus 5. So go ahead and differentiate f dashed of x. Hopefully you've tried this, paused it and tried it. But negative 1 down the front, so negative 1 sine 4x minus 5. It should still be in a bracket. and that's to the negative 2. I'm going to drop 1 off the power, and then want to start multiplying by the derivative of the inner parts. So next inner function would be the sine, so sine differentiates to cos, so cos 4x minus 5. And remember, you could use your trig rules from higher here, so if you need to remember them, you could do it in one step. And then the innermost function would be 4x minus 5, which just differentiates to 4. So that's what we get there, and we'll just tidy this up a wee bit. So the negative out the front, negative 1 out the front, so just negative. And what I might do in just one step as well was just bring this negative 2 power down to the bottom. So I would end up with negative 4 cos 4x minus 5 on the top line, and then I've brought this square bracket down the bottom to make it a positive power. So that'd be sine squared 4x minus 5. It's quite a nice one to come back and try it with the quotient rule once you learn that in a few lessons time, and see if you can do it using the quotient rule and you get the same thing either time, both times. But there we go. So that's a chain rule and a load of different types of examples. So hopefully you've got an example for each of the ones you're going to try in your practice